3, 2, 1, go. And we're live. This is Retraice segment number 94 for Sunday, December 25th, 2022, 4 p.m. Eastern, 1 p.m. Pacific. Retraice is about what's going on out there. The short answer to that is computer control. All right, listen, I'm going to tell you now, I am unusually sleep deprived. I turned all this stuff off. I'm only telling you that, not because I want any sympathy. I deserve none of your sympathy, but I'm not going to be quite myself today. I'm a bit brain fried because of the sleep deprivation. So if I can't put the words together, I can't do this, can't do that, that's why. But that might make it more entertaining, not less. Okay. We're working on best first search. We're deep into the weeds, and I'm having a good time, but it's going long. It's going way long. What, we got 13? What is the, okay, it doesn't matter. Listen, we got to have made some progress, right? Holiday or no holiday, right? I can't show up to this one, number 13. Is it 13? And not have something to say other than, what about this? What about that? All right, look, I have something to say other than, and what about this? What about that? I think let's just talk. I think it was working. That 2, 3, 4, 10 days ago, whenever it was, where we got was it Dada? That was our goal state. I don't remember if it was Mama or Dada. We got back a goal state, and I could dig it up in the notes, but it's not worth it. What we didn't get was all the information about because you don't get back a goal state. You give a goal state, but you should get back a node, and a node has a history and a cost and is a solution thereby. I think we had it. We just didn't know how to print it to standard output. Now we can print it to standard output. Let's have a look-see. You are looking at the usual file in both windows, the same buffer here. Best first search is the implemented algorithm we're running. Our problem is tproblem, and our function, hang on, let me just make sure I'm tprob, there we go. This is our problem that we're going to pass. Our function is, just out of the window. Hang on. No, yeah, it doesn't matter. I'll do that. Okay, our evaluation function is f. It just returns fu. And we're going to be working through these first few lines and then all the rest of the lines, but not, look, this is not, also I should say, this is not going to be a long segment, because it's a holiday, and also I think I've got some stuff to show you that won't, stuff to show you that will not take long to convince you that we're on our way here. We're going to be in business very soon. Okay, as we work through the first couple lines here, nodes, pretty straightforward. We just make a node out of the initial state of your problem. Frontiers, we're a bit iffy on this. It uses PriorityQueue, and it uses a little bit of syntax. It looks like it's taking our node, which is a node object, as defined by, over here, our class node. It's taking our node and turning it into a list in square brackets, I think. Our key, variable and argument into the PriorityQueue object or class is our function f, which just returns fu. But to be a node, you have to go through this process here, and so our node is doing that. I didn't put any feedback there, but everywhere else, I put feedback into our best first search. So we've got a print here, and we've got prints everywhere. Okay, look at all those prints. Now, this is like poor man's debugging. I don't know how I'm supposed to, and it's not debugging either. It's like there's no bug. We're just not sure that the program is doing what we think it's doing, because the only output we're getting is not convincing. Okay, we were getting just a return of a string that looked like, it was a node. It was a representation of a node because it was in the Pacman, but we weren't getting any information about the cost or the path but any of this stuff. Well, we got it now. This is exciting. Okay. So I put all these prints here, and now let's watch them in action. So what we're going to do is the usual thing. I'm going to just switch like this because you don't really need to see the source to see this happen. How do you spell Python? Okay. Let's load our file. Red94. 94. Okay. Our file is loaded now. I think the only thing I have to do now is best first search on our problem. Okay. So it's taking T problem. Again, we've already defined T problem in our file here. So it's taking right now, our problem is to get from state A to state dada using the T map. And T map is the combination of the T links and T locations here. This is our state space. Okay. So that's, and then F, we've already talked about F, is our FU function here. Okay. So that's all that you're seeing here. We just loaded the source file. Let's see what happens. Bang. That's chatty. That's some chatty chat. You know, I should show you, because why not? Re-AIMA CD 90, when did it start? Let's say 92. IPython. Oh, this is, I shouldn't do this because this isn't going to work out. Load. No, we're going to do 92. And can we do best first search on T problem? No, what a T problem is not defined. Okay, T problem is, let's make it 8. Same T problem back in Re92, okay? T map is not defined. Oh, you're kidding me. T map is the usual thing. Why is it, why do you need, why am I explaining this to you? This time travel is not what it's cut out to be, made out to be. Let's run, okay, best first. So we provided the T problem and the T map. Let's see if, it's probably going to want F now, right? No, I just gave, oh yeah, because I didn't do T problem because I didn't have map. There. F, okay. We will get there, we will get there. Define F there and return D value. No, T value. I don't think it matters. Now, can we just, that, okay? Look, that's how it was when we first had the breakthrough. We just get back the string in the pacman, okay? Now, it turns out, as we discovered, I think, yesterday, that these pacmen are defined by us. How do I convince you of that? I did it yesterday, but let's do it today just for spits and giggles. What do they say? If you don't want to swear, there's a anyway, CD92 and Emacs. Just any, there's only one file in there, and no, because my desktop thing doesn't work. Let's do, what is it? I think it's just this and this. Yeah, there. Okay. So when we instantiate a node, okay, this is the pacman. This is where this is coming from. So the representation of the node, that magic method returns the pacman, which is just the state inside pacman. Okay, that's what's going on there. We don't need any of this to do what we're doing today. Okay, I'm just taking you back in time a little bit there so you can understand the difference between what you see here and what we just went through. So now when we do best first search on our T problem, we get all this chattiness. Now, what is the chattiness? Well, it corresponds to all those print statements, okay? I put a bunch of print statements, best, and all these print, oops. Now I'll do this. All these print statements over here in our, you should be looking over here and down. All these print statements are what's causing all this chattiness. And so we've got just me telling us what's going on here. This is priority queue after self.key equals key, and key value is FU. Interesting. Okay. This is priority queue self.items. Okay. So that second, so that's this one here. No. Oh, because this the first one starts in a node. Does it? Yes. Okay. So that first one is, this is priority queue after self.key. And then what's the key value? And I just gave it like a dummy value, you know, because this is our F function. I mean, I don't expect you to remember that. We're jumping around a lot here, but that's what the key is here. Okay, so we're passing a second argument to priority queue. Our second argument to priority queue is here. Okay, it's this. We're passing F, and our F is just returns FU. So what do we get from priority queue? We get this. Okay, and that's sort of like we just go through the whole thing sort of in that way. Just chatty. Tell me what does the reached dictionary look like here? What does the frontier.items list look like here? What does it look like after the next step? What's the child state that you're gonna, okay? So all that good stuff is now sort of transparent to us. And what that is why I'm beginning, and no, we shouldn't be surprised by this. Like, I didn't write this code. Like, I wrote all the crappy parts of it, but we copied this code from the AIMA Python implementation, AIMA's official Python implementation. It's not official. I mean, it's not like done, and it's not comprehensive, and it's not even necessarily lint-free or even kind of lint-free. But we shouldn't be surprised that the code works. What we're here to do is to, I wouldn't say test our chops. We have no chops. I'm not a programmer. Mathematical disclaimer, I am not a programmer. Programming disclaimer, I'm not a mathematician. But we need to be able to work the code. Like, we're not going to build the cars, but we need to be able to drive them, change the oil, replace the battery, and, wiper fluid. This is the basic stuff. You can't be taking it to the shop every single time a light comes on or your wiper fluid's out or you need a refill of gas in the tank, okay? That's all we're trying to do here, is to be able to take it to the gas station if it needs gas. The petrol station, even the petrol station. So that's what I'm starting to feel like we can do here. When we do everything we need to do in the source code, which is a lot, but it's also like we're not borrowing their actions here. Okay, this is ours. This is our little toy. I mean, some of them are, but we didn't. If we wanted to use all their stuff, okay, we would be just pumping in their actions dictionary. The AIMA people, their actions dictionary. We'd be pumping in their states dictionary. Okay, we would be using the term Romania. We would be doing everything the way they do it, and we're not doing that. We're using the parts that we understand for the most part. Now, we can sort of qualify that a little bit. I really do feel like I stop understanding well enough when we get to PriorityQueue. Okay? Could we keep going? Well, now we're getting into it's quite a coincidence that we have to take priorities seriously, and it just so happens that becomes readily apparent when we get stuck on something called PriorityQueue. Could we keep going with this and prove? Could I keep going with this and prove to you, or could we keep going with this and prove to whomever that I can figure out what PriorityQueue is? I can figure out how it's a heap, and then why there's a for loop after the heap, and then why this is in this state. I mean, can we keep going and get to the point where and get to the point where every single one of these lines I can rattle off in a paragraph? It's like, yeah, okay, we get it. Like, that's over-optimizing. Okay, where is Hamming? Damn it. He's got to be close. This, here. Okay? We are systems engineers. Okay, we can call ourselves engineers in private and in secret, but we can't actually do that in public or we're going to get laughed at. We are systems engineers. This is The Art of Doing Science and Engineering, subtitled Learning to Learn by Richard Hamming. He has a couple of chapters in here on systems engineering, and there are some key points to be made. The one that's relevant here is that over-optimizing a component of a system can often degrade the performance of the system overall. In fact, I think the way he puts it is it does. Basically, as a rule, if you over-optimize components in a system, you degrade the overall performance. What that means for us is if we over-optimize on best first search, or our understanding of the components of best first search in particular, I know I could understand all this stuff better if I keep going, but it is the 25th. We are going to do a 6-month. We're studying artificial intelligence. We're studying AIMA4e. We're doing a 6-month deep dive on AIMA4e, not on any particular one part of it, but the whole system of knowledge. If we over-optimize, blah, blah, blah. You get the point. I'm going on too long because I'm tired. Okay. I'm not going to, I think I'm going to do one more segment on best first search. And, I know I haven't really talked through here each one of these steps, but I mean, if you look at this, and this will be in the notes so you can kind of comb through it and start to decide whether you agree with me that we're really doing, here's the most convincing part, the end, okay? Here's your goal. Dada booyah, dada 4, mama booyah, dada 337. How are you not convinced after that? I mean, right? That's what you were expecting. Dada booyah, dada 4, mama. That's the, okay, so what is that? That is the part, that and seeing the, the up and down hill of dictionaries and lists printed out here, showing that instead of what we saw in Re92, where all we got back was just this sort of, like somehow our implementation accidentally just returned the node form of our goal state. Instead of getting that back, okay, we get that back. This thing is working. Of course it is. We didn't write it. We should be worried about it working if we wrote it. We didn't write it. We assembled it. And once we added our chatty print statements, it's okay. So, and that last, this is your goal statement. Let's have a real look at that to see what I'm printing there. This is your, where is it? Of course. No. Where the hell? I don't know where it is. Hang on, what does it say? Here is your goal. That's why I can't find it. Gee. Here is, for Pete's sake. I told you I'm tired, people. I warned you about this. You stayed. It's your fault. Here is your goal. Okay, that's the one we want. Okay, so this statement here, this is what happens in best first search when you get to the goal state. The state of so you're working with nodes. When you're doing best first search, you're working with nodes. But you can always check the state to which that node corresponds. And you should. Because if you happen to be working with the node, a node that corresponds to the goal state, you need to stop. You need to stop and do what? You need to return that node. You need to get back to your boss and tell him, hey, I finished the job. What next? Okay? And that's what the implementation, the AIMA official implementation does. However, we needed a bit more here. Can we just say a little bit about this goal? I mean, can you just talk about the work that you did? Maybe tell me, what's the node called? What's the state that it corresponds to? What's the length of the node, the parent, the action that got you there? I mean, where did this thing come from? What was the cost? Got it. This is the node. Booyah convinces us that we're actually dealing with our little customization. Dada is the state to which it corresponds. That's our goal state. 4 is the, what is the 4? The length of the node. Oh, geez, don't do this now. The length of the node is 4, and what is the? I think that's is that the number of hops? I don't remember what the length. Oh, come on, let's just. Well, I'll come back to length in a second. And then the parent is Mama Booyah, and the action that was applied to Mama Booyah is Dada. Well, that sounds a bit racy, but that's what happened. And then 337 is the path cost, and the path cost is I haven't done the arithmetic to confirm this, but each one of these are the actions. Okay, these pairs of states plus the number next to them represent actions. This is the action going from A to Z, traveling 75 miles to get from. We're gonna have to just do this, aren't we? No, I'm not doing it. I'm not doing it because it's gonna go long and there's no point. You're either convinced or you're not convinced that this is the data that we're getting back. You can go check the math yourself, and maybe I will later before I print up the notes. But that's, we're talking about the job done. You're showing your work. Show your work. Best first search, please show your work. Well, now I think that's what we're seeing there. Okay? I think that and the really verbose version indicate that this is working, that we didn't accidentally get something to just return data and pretend like it. And anyway, it wasn't when we had it in the Pac-Man, when we had Dada and Pac-Man, I don't know, what are you supposed to call these? Greater than, less than every time. What are they called? Anyway, Pac-Man. That is not an acceptable standard output. That's not acceptable data to the user who is calling best first search, giving it these arguments and saying, hey, that's not a solution, but the data was there. It's just that their implementation was not printing it to standard output. And why would you? Because you're probably going to use it, as like API style. You're going to connect it to something else. You don't need. Look, one of the rules of Unix philosophy is don't say anything if there's nothing to be said. And if you've done the job and you finished it, don't say anything at all, and just be ready for the next job. That's fine, unless you're not a programmer and you're trying to figure out whether you can do adequately at filling up the gas, changing the oil and the wiper blades on programs before you go deep dive into AI. Okay, so that's it. I think I'll do one more and do a recap. I got to do a recap. There's 13 of these things. It's going to be 14 by the end. I'll do a recap. I don't know if I can pull it off by tomorrow. We might do a 2-part recap, right? Everyone's going to be glad I did that. But this thing is working. It's working. And remember, we weren't studying the AI of it, and we're not trying to teach programming. And later, these things will seem easier as we've done a lot more coding. But for now, I think it's in a good enough. You know what I'll do tomorrow? I'll run it on the official Romania problem. That's easy. That's what I'll do. Because I'm not going to have time to do a full recap of this thing. But you know what I'll do? And I knew I was going to do this. I just forgot. Actually, I don't need that. So let's do this and do this and do this and do this and do this. And okay, so I'm going to do these problems down here. Okay. The only thing I don't know is, like, how do you check it? But I don't know. I'll figure that out. Your confidence increases, based on a lot of things. But how do you check it? You do it manually. We have a map. We know how to do this. No. It takes 2 tries sometimes. Okay. Notes, retrace. Oh, no, this is not good. Where do we start? Like, what number are we at? I will show you how we're going to check it, okay? That's all I'm going to do, and then we're done. Because it's Christmas. All right. Oh, come on. I don't know. It's been a long time. It started like 82 or something crazy, didn't it? Okay. There. Okay. Actually, this doesn't show. Oh, I didn't even need to do this. Romania. Okay, we just need this. This is what I need. Okay, so we'll check those. So when we go tomorrow, when we run these problems through our best first search implementation, we will, okay, so R0, route problem 0, route problem 1, 2, 3, 4, okay, to get from A to A, and then A to B, and then N to L, and then E to T, and then O to M, all using the map of Romania, this map of Romania, okay? We will check them here. That's going to be a pain in the ass, but we're going to do it. All right. All references and notes and everything will be in the PDF notes. Get those done ASAP, as usual. Website is retraice.com, retraice.com. This has been segment number 94, and we're going strong, and we will be... I was going to do 4 p.m. tomorrow, but I'm thinking I'm going to have to do 10 p.m. tomorrow. Tomorrow's busy, but will either be 4 p.m. or 10 p.m. I don't know what works for your schedule, but my schedule is the one that has to be in charge. All right, signing off.